Good morning. Survival. We're driven by it. Recently, a fisherman off the coast of Mexico was set adrift. Floats across the Pacific Ocean for a little over a year. 6,700 miles away on the Marshall Islands, he washes up alive. And then there was the Russian physician in Antarctica suffering from an acute case of appendicitis. He had no other option. He removed his own appendix. It's pretty obvious that survival is a powerful driving force in organisms, a force that's been programmed into our genes by Mother Nature, driven at times extrinsically by fear, but intrinsically by evolution. So an organism that does something that would intentionally decrease their chances of surviving would appear out of place. My father is an interesting man, an intellectual jack of all trades. I recall as a child growing up having conversations with him that were many times well above my head, but quantum theory, how it affects our perceptions of reality when you're 7 years old. Plate tectonics and the geological evidences to suggest that. The Napoleonic Wars, one of his favorite. Origins of democracy, Darwinian evolution, one of my favorite. What I remember most about my father was his selflessness. Many of the conversations that we had a common theme. It wasn't about the individual. It was about the group. This idea was etched into my psyche as I grew up. It wasn't about me. It was about us, all of us. Now, some of my father's viewpoints may have come about with through his life as a career soldier and his service in Vietnam. As a career soldier, he wasn't drafted into the war or into service. He went there willingly as part of his duty. That anyone would put themselves in an environment like that drastically reduces their chances of surviving seems to me an interesting paradox. After all, if it's true that survival is the ultimate goal, and it certainly seems to be, then why take a bullet for someone? Why do human beings do some of the courageous and life-threatening things that they do in order to save each other? In order to understand the way this works, we're going to talk a little bit about evolution. Evolution is change, simply put. Everything evolves, living and otherwise. Geologists speak of the evolution of Earth. Anthropologists, archaeologists talk to us about cultural evolution. Even businesses evolve. What's it mean biologically, though? Biologically, to evolve, to adapt, is to survive. And for that, you need numbers. So whether it be longer ears, better camouflage, feathered reptiles, or fish with legs, these organisms survived better because they were more fit than their counterparts. You see, those genes that increase our chances of surviving contribute to our fitness. In turn, those genes will be passed down in higher proportions to successive generations simply because more fit individuals reproduce more. Everybody out there with their unique set of genetic information is competing with everybody else and their unique set of genetic information, and the winners are those who reproduce more than everybody else. That's good. What about altruism? That's an interesting behavior we see in humans and other species. It's defined as when one organism sacrifices their health or even their lives for another. Something we generally consider honorable and courageous. And yet it's something from an evolutionary point of view, from a biological point of view, that might seem foolish. Case in point, the fur-rit monkeys of Africa. Fur-rit monkeys live in groups of various degrees of relatedness, and when they're out foraging, they watch over for predators. If a predator is detected, these monkeys are capable of such complex alarm calls, they not only can indicate the presence of the predator, but the type of predator they're dealing with. Amazing. Now, while this alerts the other monkeys to danger, it unfortunately brings attention to the alarm-calling monkeys, putting them at risk. And biologically speaking, the death of an organism removes that organism's unique genetic information from the planet. So why would anyone act in such a way that increases their chances of decreasing their chances of surviving, passing on their genetic information to their offspring? After all, this seems to fly in the face of Darwinian evolution, which says that organisms should act in ways that increase their chances of surviving, having more offspring, passing on their genetic information. In order to understand altruism, we must understand survival not from the individual, but from the group basis. Here, the focus is not just on your individual genes, it's on something known as a genome. A genome is a collective set of genetic information. An individual represents a genome, as does a family. A group or population of meerkats have a genome. Animals, we have our own collective genome. Fungi even have a genome. Protozoans have a genome. It is the genes in the genome that give the collective the best chance of surviving. Now, this survival of the collective or of the group is known as inclusive fitness, and it is this that provides the genetic reasoning for altruism. It is the genetic fitness of the genome that is most important in Darwin's theory. Evolutionary biologists speak of something known as the Hamilton rule. It's a theoretical rule used to predict when and why an organism would sacrifice themselves for another. And it basically says that which you are most closely related to is that which you are most inclined to risk your life to save. The key is relatedness here. Increased degree of relatedness means there's a greater chance that you'll act in an altruistic act to save that person. One component of the Hamilton rule is the benefit to the recipient of the altruistic act, the person being saved. And the benefit is measured in potential future offspring. So the idea here is that if the altruist is successful and saves the recipient, these are the potential future offspring, and don't forget the passing on of genetic information that's afforded to them. Another component would be the cost to the altruist. It's also measured in potential future offspring. But in this case, if the altruist dies during the act, they obviously incur no future offspring, nor the ability to pass on their genetic information. The Hamilton rule then predicts that altruism should only occur when the benefits are greater than the cost to the altruist. That's not over yet. The cost to the altruist involves the probability the altruist dies during the act, okay? And it could be argued that any altruistic act has with it some degree of chance of dying. So if this is true, then any chance of the altruist dying, however slight, is going to cause the cost to the altruist to be greater than the benefit to the recipient. This here would suggest that altruism should never occur. And yet it does. That's because there's one more component that I've been talking about, the degree of relatedness. R balances out the probability of the altruist dying during the act with the degree of relatedness to whom the altruist is trying to save during the act. I'll give you a couple of examples. You're more likely to save your brother in a higher degree of relatedness from a vicious dog than you would say, it can be vicious. My daughter has one. Then you are, say, saving a cousin with a lower degree of relatedness. Now, I don't know about you, but all bets are off if my brother or my cousin suddenly were found on the menu of a hungry white shark. In that case, they're on their own. In its most pragmatic form, for a given situation, the Hamilton rule predicts who you will save based on your degree of relatedness. Anthropologists tell us humans arose on Earth 6 to 7 million years ago. Modern humans all descended from a single female ancestor that lived in Africa 150,000 to 200,000 years ago. It's this commonality that strikes me. For no matter how far we branched from each other in the last 150,000 to 200,000 years, we still share quite similar genomes. That is a mere sliver of Earth's time. It's undeniable that we are still very closely related to one another. So if we accept the fact that our propensity to engage in altruism is dependent upon our relatedness, on our similarity of genomes, then to me, caring for each other comforting, nurturing, feeding, educating each other, even taking a bullet for each other may not be solely a moral obligation, but a genomic one as well. Thank you.